Okay, let's have a look at question 10. So question 10 is dealing with your calculus section. We're dealing with the cubic function over there. So they give us the function h of x equals to ax cubed plus bx squared. And then the graph has a turning point at 0 and 0 and at 4 and 32. Okay, and then it says a is an x-intercept of h. So 10.1 says show that a equals -1 and b equals to 6. Okay, so we've got two unknowns here that we're dealing with, a and b. So we need two equations. So the first equation is just using this one as is, but now what do we know? We know that this point here is 4 and 32. So we can find h of 4, which equals 32. So 32 equals to a 4 cubed plus b, and then we're doing 4 squared. Okay, and if you sort that out, 4 cubed gives you 64. So 32 equals to 64a plus 16b. Okay, now the next equation that we can use is using the derivative of the function, and we know that at this point over here it's a turning point, so the derivative must be equal to 0. Okay, so I'm going to do that over here. So we can do h prime of x, okay, which is then going to equal to 3ax squared plus 2b x. Okay, and now we're looking for h prime of 4 equal to 0. So therefore we have 0 equal to 3a, let's see, that's 4 squared plus 2b times 4. Okay, and therefore we're then going to have the following equation over there. That's going to be, if we substitute that in, that's 48 a plus 8b. Okay, we can simplify that because it's equal to 0. So if we simplify this, we can take out 8 as a common factor, which means we have 0 equals to 6a plus b. Okay, now we've got two equations with two unknowns, so we've got to solve it simultaneously. So we could make b our subject over here and then solve, or you can just say, let's say this is equation 1 and this is equation 2, so you can say equation 1 minus equation 2, okay, or vice versa. You can make this one 1 and that one 2, it depends on you. Okay, if we solve that, so let's see, if we make, let's make this one 1 and that one over there number 2. Let's see, can this number 2 be simplified? 16, 64 and 32, yes we can. We can take out 16, so this becomes 2 equals to 4a plus b. Okay, so now if we say 1 minus 2, so equation 1 minus equation 2, okay, we're then going to get equation 1, so 6a minus or plus b minus 2a plus 4, okay, and then that is going to all equal to 2, okay, because it's 0 or 2 minus 0. Okay, and then if we sort that out, we get the following equation over here: 4a plus b equals to 2. So if we solve that over there, what am I saying? What's going to cancel out here? That needs to be 2a over there. Where to get the sorry, we're taking this one, we're minusing this one over here, so it's minus 4a plus b. Okay, so you can see the b's and the b's are going to cancel out, okay, which means we then end up with the following equation over here of 2a equals 2. So therefore we can see that a equals -1. Okay, so sorry for my mess up over there. And because a now equals to -1, if we substitute -1 into here, we're then going to get that b equals to 6 as wanted. Okay, so now we have that equation, which is h of x equals to -x cubed plus 6x squared. Okay, now let's have a look at 10.2. 10.2 says calculate the coordinate of a. So we know that a is a root, okay, that's very important, and we've just found the formula for the function, so we can just set this equal to 0. Why? Because in order to find the x-intercept, we make y 0. So let y equal to 0. Therefore 0 equals -x cubed plus 6x squared. Take out x squared as a common factor. Okay, if we take that out as a common factor, we're going to then end up with negative x plus 6. Okay, and we know that a can't be where x equals to 0, so therefore a must have this coordinate over here, because we'll have x squared equals to 0 or minus x plus 6 equal to 0, so therefore x will equal to 6. So a's coordinate, don't forget to write it in coordinate form, is then going to be 6 and 0. Okay, now if we look at 10.3, it says write down the values for x for which h is increasing. Okay, now important thing there is when h is increasing, it means that your output value, so y2 needs to be greater than y1 when x2 is greater than x1. So just be careful of that. Okay, so as your x values increase, your y values need to be increasing, or you can find where the derivative is greater than 0. Okay, but just by looking at the graph there, where is the gradient of the graph increasing? So if we look over here, this is 0, and that's 4. So we can see here, this will give me a negative gradient all the way to here. Then we have a turning point, and then this becomes positive gradient again, meaning it's increasing there, and then it's negative all the way there. So therefore, it's increasing between 0 and 4. So you can just say that x is an element of 0 to 4. Okay. You can use including brackets as well if wanted. Okay, now it says 10.3.2 says concave down. Okay, so concavity always deals with the second derivative. Now, the thing is, for concavity, we need to find the inflection point. So we find the second derivative equal to 0. Okay, so earlier on, have we found the second derivative yet? No, we haven't. Okay, so let's quickly find the second derivative of a function. So our function h of x equals negative x cubed plus 6x squared. So the first derivative of that is going to equal to negative 3x squared plus 12x. Therefore, the second derivative is going to equal to negative 6x plus 12, and we're finding where that equals to 0. So if we solve for that, let's have a look here. We're going to have minus 6x equals minus 12, so x equals to 2. Okay, so therefore my inflection point is going to be at x equals to 2. Now we substitute 2 into our equation over here. Okay, and if we find that, okay, we actually don't need to find the y value. Why? Because we're looking for the x values. So that's not actually relevant at this point in time. So let's look. Concave down would be, if we're looking at concavity, okay, so concave up, concave down. So it makes the function look like a hill. Okay, so concave up is a valley, concave down is a hill. So if we're looking for concave down, it will be then from our inflection point of 2, so x is an element of 2, up until infinity. Why? Because the function runs for infinity. Okay, so I don't include my my inflection point. Okay, now the last one says 10.4 says for which values of k will the following function there, so negative x minus 1 cubed plus 6 x minus 1 squared minus k equals 0 have one negative and two distinct positive roots. Okay, so let's have a look at this. If we draw, let me just redraw the function here quickly. So this is what our function looks like. Okay, and now what's happened here? At every x we've minus 1, which means we've shifted the graph to the right. So our new graph, if I draw it in blue, is going to have shifted 1 unit to the right. So let's say it is now sitting over here. Okay, that's increased 1 unit to the right. So we can call this f of x, which equals h of x minus 1. Okay, so we want to know where will this have a distinct positive or two positive roots and one negative. Okay, so at the moment it's the black graph. If you look here, it's got 2 roots at 0 and 1 positive root. So now we need 1 negative root and 2 positive roots, which means I need to shift this blue graph down until I create that. So I need to shift it down until we have something like this. So let's say that's now our second turning point. There we've got a negative root comes up, there we've got a positive root. Okay, and then we have another positive root there, positive and negative. So how do we solve for this? Well, if we look at this, okay, we know that if we make this function equal to 0, or the x value equal to 0, we can then solve for y values, because we need to find this intercept over there. So we want to find f of 0, which equals h of 0 minus 1. Okay, so therefore we're going to end up plugging 0 into wherever you see x, so minus 0 minus 1 cubed plus 6, 0 minus 1 squared minus k. And if you solve for that, okay, we are going to get a value of, let's see, that's negative 1 cubed times 1, that's 1 plus 6, which equals 7. Okay, so the minimum that we can go for an x-intercept is 7, okay, so where y equals 7, and the maximum we can go is this original turning point up there. So if I shift this function back to where it was, then I end up with 2 positive roots here. But if I continue shifting it down to a minimum of negative 7, okay, where x equals to 0, then we have this point here as negative 7, then we can do this. Okay, so what must k be? K needs to be 7 units because it's already indicated as negative over there. Okay, so our k value is then equal to 7. So therefore we need k values to lie between 32 and 7. Why 32? Because if my maximum turning point's at 32, my minimum is then going to be sitting on the x-axis. Okay, so therefore we're not including it because that is the maximum we can go, and the minimum we can go for k over here, because it's negative, will then be 7 units. Okay, and that's how we go about doing this question. Okay, if you're finding the content helpful, then please leave a thumbs up on the video. It does help me out quite a lot. If you are enjoying the content as well, then please consider subscribing to the channel. If you have any questions regarding this question, then please leave it down in the comment section below. I'll get back to it as soon as I can. And remember, it's never too late to have an OIC moment.